So in this video tutorial I'm going to walk you through from the beginning how to create a project in which the DEMs actually were derived from different survey methods. I'm going to take you to a place in Central Oregon. This is Bridge Creek and a little reach called Pat's Cabin. And so I'm going to make a new project here. Just call it Pat's Cabin example. And first thing we're going to do is go into the survey library, and we're going to add our survey, and I will grab that. I've got these files here, so I'm putting my project in this Pat's Cabin example 1 folder, and then I've got my existing data in this Pat's Cabin, this 24 Pat's Cabin folder. So we're going to grab the 2010 DEM here, and we bring that in the standard way. Now, I'm going to just warn you that this tutorial is going to take a little longer than some because this particular data set has 10 centimeter resolution grid, so it's quite a bit larger. And so right now it's loading that, and one important thing when you're working with bigger files is when you're loading these DEMs you want to be really patient because there's no status bar telling you what's going on here, but we can see it's loaded the hillshade that it calculated and loaded this DEM in the background. And what we've got is a hybrid survey here, and so instead of using the single method survey we're going to use multi-method. And I have a shapefile in here, and that shapefile has all of the polygon masks that tell me which part of the DEM was created with what type of data. So I'm going to go ahead and I'm going to hit add on this. It's very important that when you do this that the shapefile is not a three-dimensional shapefile. It's not a ZM enabled file. It needs to just be a flat shapefile. So it's brought that in, and then we've got this method here, and the method is a text field inside of that shapefile that describes what the techniques were for the survey. So I'm going to go ahead and hit Save Survey and come out, and we'll take a look at what we've got here. So here's the different methods, and I'm going to switch this to categories, change over to method. I'm actually going to import a layer file that has different symbology here. And so now we can see that this area with the orange hash, this is all airborne LiDAR. This area with the yellow diagonal hash the other way is RTK GPS, and then this brown hash is ground-based LiDAR or terrestrial laser scanning data. And so those were the different data sets used to make this composite hybrid DEM. And so what is a real problem with dealing with this data in a change detection context is how do we calculate an error grid when we've got these three different methods? We certainly can't calculate just a uniform error for the whole thing. And so because we've entered in that mask, we can see now in here we've got 1, 2, 3 for the different methods, and it got those methods from that shapefile. And notice it's already populated these with the default values for each of those methods. I could change these individually if I wanted to, but I'm just going to stick with those for now. And I'm going to call this multi-method all uniform errors, right? But they're going to be different errors. And so when I hit OK, in the background here it's going to start calculating the error surface, and what I should see is uniform errors for each of these different polygon masks. So again, this is a 10 centimeter raster, so this could take a bit. This is where I'm supposed to have some jokes to fill the silence. There it goes. Okay. So it completed successfully. And we can see here that if we query this guy, we've got 6 centimeters for all the GPS, we've got 3 for all the TLS, and we got 15 for the others. And so that's how you can create a multi-method raster. I'm going to show you one other example, and this one really will take quite a bit longer. Go back into the error calculations. We're going to calculate errors, and this time what we're going to do is we're going to use a fuzzy inference system for one of these. Before we do that, we have to have associated surfaces. So I'm going to go ahead and let it do a slope analysis for me. Okay. And so there's my slope analysis associated surface, and then I'm going to load in a point density surface that I already have. It's good to be patient with these things. Wait till this dialog gets populated. And I'll change that to point density. And now I'm going to go over, and for the RTK GPS, I'm going to use the GPS fuzzy inference system. And I'll use the slope raster, which is for everywhere, but it's only going to calculate it in this area here for the fuzzy inference system. And I'll use that point density. And I'll call this multi-method RTK FIS. So I click OK, and last time I did this it took about 10 minutes. So I'm going to cut this portion of the video out. And I will tell you that as long as this wheel is continuing to turn and it says calculating air surface down here, and then the really reassuring thing up here is the not responding, that means everything's probably okay. So grab yourself a cup of coffee and wait patiently. Either that, or you could work with lower resolution rasters. So we waited and waited and waited. It took us about, let's see, it took about 7 minutes for that to calculate, but it finally did calculate here. And I'm going to hit save survey and come out. And what I've got here is a multi-method inference system is included in here. Fuzzy inference systems included. I've got these uniform areas which are different for the looks like for the TLS survey versus for the airborne LiDAR. And that has completed successfully. So now I can go ahead and I can use those in subsequent GCD analyses, and that's a pretty powerful tool. So that's all she wrote.